Let's take a look at how we check if a point is a solution to a linear relation. Our rule today is y equals 7x plus 1. To find the y values, we plug the x value into the equation. When x equals -1, y equals 7 times -1 plus 1. So, y equals -6. When x equals 0, y equals 7 times 0 plus 1. So, y equals 1. When x equals 2, y equals 7 times 2 plus 1. So, y equals 15. Let's move to part B. Now we are given a pair x and y, and we have to see if the left side equals the right side. If yes, it's a solution. If no, it is not a solution. Test 3 and 22. Is 22 is equal to 7 times 3 plus 1? Let's solve. 22 is equal to 22. This is true. So the coordinates 3 and 22 makes the equation true, therefore it is a solution. Let us test 0 and 0. Is 0 equals 7 times 0 plus 1? Let's solve. 0 equals 1. That's false. The coordinates 0, 0 does not make the equation true, therefore it is not a solution. Let's test -2 and -15. -15 is equal to 7 times -2 plus 1? Let's solve. -15 equals -13. That's false. The coordinates -2 and -15 does not make the equation true, therefore it is not a solution. Always remember that in an ordered pair x and y, the first number is your x value, which we also call the input, and the second is your y value, which is also known as output. If the math doesn't balance, the point doesn't exist on that line. Ready for the next question? Let's go. Let's have a look at this question. We're going to talk about symmetry. Think of a line of symmetry like a folding line. If you fold a shape along that line and the two halves match up perfectly, then you have found a line of symmetry. Let's break down these three shapes quickly. The rectangle is very balanced, but it is a bit tricky. If you fold it right down the middle from top to bottom, the left side lands perfectly on the right side. That's one symmetry line. If you fold it across the middle from left to right, the top lands perfectly on the bottom. That's another symmetry line. But how about diagonals? If you try to fold a rectangle from corner to corner, the corners won't actually line up. Therefore, a rectangle has two lines of symmetry. Moving to the isosceles triangle. Remember, an isosceles triangle is the one where two sides are exactly the same length. Since the left and right sides are a mirror of each other, we can draw one line straight down from the top point, the vertex, to the middle of the base. Are there any other symmetry lines? Let's try to fold the triangle from any other corner. The sides won't match because the base is a different length than the sides. Therefore, an isosceles triangle has one line of symmetry. Moving to our last shape, the parallelogram. This is the one that usually trips students. It looks like a rectangle that's leaning over. If you try to fold it vertically, the leaning corners will point in opposite directions. If you try to fold it horizontally, they still won't match. Even the diagonal fold fails because the angles are slanted. Because the shape is tilted, there is no way to fold this specific shape, so the halves match perfectly. Therefore, a parallelogram has 0 lines of symmetry. Ready for the next question? Alright, let's take a look at this geometry question. We are going to rotate this square, which is another way of saying we are going to spin it around a specific point. Let's think of this as a fidget spinner or a wheel. There is a center point that stays still, and everything else moves around it. Before we spin anything, we need to know where the anchor is. Looking at the graph, the problem tells us to rotate it about its center. Now if you look at the square ABCD, the center is that little circle icon at the point 30. This point will not move. Everything else will move around it. The question asks for a rotation of 1/4 of a turn clockwise. Now 1/4 turn means 90 degrees turn. So, if the square was standing tall, it's now going to be lying down on its side. Clockwise is an indication for the direction the square will move, and this means it will turn to the right. Now, when you rotate something around a point that isn't 0, 0, it can look tricky. But here is the easiest way to visualize it. Since the shape we are rotating is a square, which means that all sides are identical, all we have to do is to imagine a line connecting the center, 3, 0, to point A, 1, 2. Now here is the trick: rotating a square at 90 degrees is like placing a mirror at the center of the shape and looking at the reflection. Let's start with point A. We have that at 1, 2. Now let's imagine a mirror was placed vertically in the middle of the square. We are imagining the mirror there because we are rotating clockwise. This means to the right. So a prime, or the reflection, will be at 5, 2 now. Let's do point B. We have that at 5, 2. Again, imagine a mirror placed horizontally in the middle of our shape. Now we placed it horizontally because we are still rotating clockwise, so our new points for B, or prime B, is 5 and -2. Let's do point C. We have that at 5 and -2. Since we are moving clockwise, we are going to imagine the mirror vertical again. So the reflection of point C on the other side would be at 1 and -2. Let's do our last point D. Again, since we are moving clockwise, to the right, we are going to imagine the mirror horizontally. So the reflection of point D on the other side would be at 1, 2. Can you see what happened? Our shape is still in place, but our points moved clockwise from one corner to the other corner. Thank you for watching, and see you in the next video. Let's have a look at this question. As you can see, we have a pie chart, and we want to find some missing percentages and angles. Here is the easiest way to solve this. Before we start solving, remember the following. Percentages must always add up to 100%. Angles must always add up to 360 degrees, because a circle has a total of 360 degrees. Let's start by finding the missing percentage. We know that if we add all the fruit percentages together, we must get 100%. So, 30% mango plus 20% apple plus 15% peach equals 65%. Now subtract that from the total. 100% minus 65% equals 35%. So, the percentage of banana is 35%. Let's move to the next column and find the angles. The fastest way to turn a percentage into an angle in a pie chart is to multiply the percentage by 3.6. Since the whole pie chart equals 100%, and we know that a pie chart is a full circle equals 360 degree, therefore, to know what just 1% looks like in degrees, we divide the total degrees by the total percentage. 360 divided by 100 is equal to 3.6. So 1% equals 3.6 degree. Having this conversion rate, we can easily convert any part of the pie chart. Take your banana percentage, 35%, and multiply by 3.6. 35 times 3.6 is equal to 126 degree. So the angle for banana is 126 degree. We do the exact same with peaches. We know peach is 15%, so multiply the percentage by 3.6. 15 times 3.6 is equal to 54 degree. So, the angle for peach is 54%. Ready for the next question? Let's look at this alloy problem. An alloy is a mixture of metals. In this case, we are mixing tin and lead. Think of ratio like a recipe. Our recipe for this alloy is 11 parts tin for every 9 parts lead. Before we solve anything, we need to know how many parts is our alloy. We have 11 tin parts and 9 lead parts. So the total amount of parts, 11 plus 9, is equal to 20. This means for every 20 grams of the alloy, 11 grams are tin and 9 grams are lead. For part A, we know the total weight of an alloy is 600 grams. We need to find how much one part is worth. Divide the total weight by the total parts. 600 grams divided by 20 parts equals 30 grams per part. Since lead is 9 parts of the mixture, 9 parts times 30 grams equals 270 grams of lead in the 600 grams alloy. Moving to part B, this one is slightly different. We aren't starting with the total, we are starting with just the tin. 220 grams of tin divided by 11 parts of tin equals 20 grams per part. We know from step 1 that the total mixture is 20 parts, so 20 parts times 20 grams equals 400 grams total weight of the second alloy. Ready for the next question? Let's go. Let's look into this pizza problem. We are going to look at 3 different ways to describe a group of numbers: the mode, the mean, and the median. Part A is asking about the modal price. The mode is just another word in math for the most used number. To find it, look at the number column. Which pizza did they buy the most of? They bought 3 margherita pizzas. Every other kind has 2 or fewer. Since the margherita pizza was ordered the most, its price is the mode. So the answer is $11. Part B is about the mean price. The mean is the average. To get the average, you add up all the prices and divide by the total number of pizzas. Now, we don't even need to do the heavy math here. Think about it. We are taking a $16 pizza, the barbecue pizza, and replacing it with an $18 pizza, the deluxe pizza. The total bill just went up by $2, but we still have the same 8 pizzas. If the total sum of the prices increases, the average, or mean, must also increase. So we choose increases. Part C is about the median price. The median is the middle number when you line everything up from cheapest to most expensive. Let's list our 8 pizza prices in order. Since there are 8 pizzas, which is an even number, the median is right between the 4th and 5th pizza. The 4th pizza is $13. The 5th pizza is $13. So the median is $13. Now, what happens if we swap the $16 barbecue pizza for an $18 deluxe pizza? Let's look at the new list. The middle of the line didn't move. The 4th and 5th pizzas are still $13. Changing a number at the very end of the list doesn't affect the middle. Therefore, we choose stays the same. Ready for the next question? Let's go. Let's take a look at this probability question. We have 2 spinners, and we are trying to figure out what happens when we add their results together. First, we need to know every possible outcome. Since each spinner has 4 sections, there are 4 times 4 is equal to 16 possible combinations in total. The addition chart in the image is the best way to see all these outcomes. You take a number from the left, spinner 1, and add it to a number from the top, spinner 2. To find the probability, we need to look at all 16 sums in that grid. For the second row, 9 plus 4 is equal to 13. 9 plus 7 is equal to 16. For the third row, 5 plus 7 is equal to 12. 5 plus 3 is equal to 8. For the last row, 2 plus 3 is equal to 5. 2 plus 5 is equal to 7. For part B, we just go through our 16 results and circle the odd numbers. Top row, we have 7. Second row, we have 13. Third row, we have 9. Bottom row, we have 9, 5, and 7. That gives us a total of 6 odd outcomes. So our probability of getting an odd number is 6 over 16. But we aren't done. The question asks for the lowest term. We can divide both the top and the bottom by 2. 6 over 16 becomes 3 over 8. Ready for the next question? Let's go. All right, let's take a look at this geometry question. We are dealing with a rotation, which means turning a shape around a specific fixed point. First, we need to know which rectangle is the original and which is the rotated one. Going back to our question, you can see that the question mentioned that rectangle OSTV was rotated onto rectangle WQTR. This means that the original rectangle is OSTV and rectangle WQTR is the rotated image. Now, the easiest way to find the center of rotation, or the anchor point, is to look for a point that didn't move at all. Let's have a look at the names of our rectangles, OSTV and WQTR. Do you see a letter that appears in both? It's the letter T. In the diagram, notice that point T is a corner for both the standing rectangle and the lying down rectangle. Because point T stayed in the exact same spot while the rest of the shape rotated around it, T must be the center. Thank you for watching, and see you in the next video. Let's look at this algebra question that tells us to consider the line with the equation y equals 15. The rule for this line is, no matter what x is, y must be 15. Keep in mind that any equation that looks like y equals number, is a horizontal line. Every point on that line will have that exact same y value. Therefore, for point A, -8, A, since this point is on the line y equals 15, its y value must be 15. So A equals 15. Point B, 13b, same rule. Since it's on the line, the y value has to be 15. So B equals 15. Moving to part B, let's talk about the slope. Slope is just another word for how steep the graph is. Look at the line y equals 15. It's perfectly flat. Therefore, the slope is 0. However, there is a way to calculate it by dividing the rise, which is the change in y value, over the run, which is the change in the x value. We are going to use our 2 points from part A. Point A, -8, 15, and point B, 13, 15. The slope formula is slope, or m, equals y2 minus y1 over x2 minus x1. 15 minus 15 over 13 minus -8 equals 0 over 21. Anytime you have 0 divided by a number, the answer is 0. Always remember that horizontal lines never change their y values, and they never have any steepness, or what is known as slope. Ready for the next question? Let's go. Let's take a look at these two triangles. We are told they are similar, which is another way of saying they are the exact same shape, just different sizes. When triangles are similar, their sides stay in the exact same proportion. First, we need to find the sides that correspond to each other. Look at the positions. The slanted sides, also known as the hypotenuse. FR is 8 centimeters matches with JM, which is 20 centimeters. The bottom sides, GR, which is x centimeters, matches with LM, which is 15 centimeters. To get from the big triangle to the small one, we just need to figure out what we are dividing by. Let's look at the slanted sides we already know. Scale factor equals 20 centimeters divided by 8 centimeters. This is equal to 2.5. This means the big triangle is 2.5 times larger than the small one. Since we know the big triangle's bottom side is 15 centimeters, we just need to shrink it back down by dividing by the same scale factor, 2.5. X equals 15 over 2.5. This is equal to 6 centimeters. Now there is another way to solve it, which is the ratio method. X over 8 is equal to 15 over 20. Simplify 15 over 20 by dividing both by 5. We get 3 over 4. Now cross-multiply. 8 times 3 is equal to 24. 24 divided by 4 is equal to 6. So x equals 6. Choose whether you want to solve using the scale factor or the ratio method. Ready for the next question? Let's go. Let's have a look at this algebra question. We are looking at a relation, which is another way of saying a rule that connects two numbers, x and y. Our rule is y equals -5.5x. This means that to find y, you just multiply your x value by -5.5. For part A, in an ordered pair xy, the first number is always x value and the second is y value. To see if a pair fits the rule, we plug the x value into the equation and see if we get the correct y. Let's start with 0, 0. 0 equals -5.5 times 0. 0 equals 0. Both sides are equal, so yes. 0, 0 is a solution. Test coordinates -2, 11. 11 equals -5.5 times -2. 11 is equal to 11. Both sides are equal, so yes, -2, 11 is a solution. Test coordinates 1, 5.5. 5.5 equals -5.5 times 1. 5.5 is equal to -5.5. Both sides are not equal to each other, so the coordinate 1, 5.5 is not a solution. Test coordinates 2, 11. 11 equals -5.5 times 2. 11 equals -11. Both sides are not equal to each other, so the coordinate 2, 11 is not a solution. Test coordinates -1, 5.5. 5.5 equals -5.5 times -1. 5.5 is equal to 5.5. Both sides are equal, so the coordinate -1, 5.5 is a solution. Test the last coordinates, 3, 16.5. 16.5 equals -5.5 times 3. 16.5 equals -16.5. Both sides are not equal to each other, so the coordinate 3, 16.5 is not a solution. Moving to part B. The question asks if -4, p is a solution. What is p? Remember, in the coordinates -4, p, the -4 is our x value, and p is our y value. Let's use our rule to find p. Y equals -5.5x. P equals -5.5 times -4. P equals 22. Ready for the next question? Let's go. Let's have a look at this geometry question. We are looking at two rectangles, and we need to figure out if they are similar and which mathematical statements correctly describe that relationship. To see if these two rectangles are similar, we compare their matching sides. Small rectangle KLMN, short side equals 4. Long side equals 8. Large rectangle ABCD, short side equals 8. Long side equals 16. Now let's see if the scale factor is the same. Short sides, 8/4 is equal to 2. Long sides, 16/8 is equal to 2. Since both pairs of sides were multiplied by the exact same number 2, these rectangles are similar. In geometry, when we say two shapes are similar, we use this symbol. The order of the letters tells us which corners match up. Let's look at our shapes. Start at K. The corresponding corner on the large rectangle is A. We follow the same path, K to L, L to M, M to N. So K matches A, L matches B, M matches C, and N matches D. So the correct similarity statement is KLMN is similar to ABCD. Now let's look at those fraction options. For a proportion to be correct, the top and bottom of each fraction must be matching sides. Look at the first option. We have KL over CD. KL is a vertical side equal 4, and CD is a vertical side equal 8. Although both are vertical sides and their ratios match, but they are not following the same order of letters as KL corresponds to AB. Look at the same fraction option. KL and AB are both left side heights. KN and AD are both bottom widths. MN and CD are both right side heights. And LM and BC are both top side widths. This pattern is correct. Always remember to match the short with the short side, and the long with the long side. If the ratio is the same for both, you found a similar shape. Ready for the next question? Let's go. Let's look at this algebra question. Finding horizontal lines is easy once you know how to read coordinates. A horizontal line goes straight across from left to right. In math terms, coordinates are written as x, y. X tells us how far to move left or right. Y tells us how far to move up or down. If a line is perfectly horizontal, its height y never changes. So, the easiest and fastest way to solve this is to look for the pairs where the second number, y, is exactly the same. Let's check our pairs. F5 -6. And M -5 -6. Looking at that, both y values are -6. The height didn't change. So this is a horizontal line. J -4 -9. And W 4 -9. Both y values are -9. This is another horizontal line. U1 3 and V1 -3. The y values are 3 and -3. Since they are not the same, this is not a horizontal line. A 6 -1 and B 6 1. The y values are -1 and 1. Since they are not the same, this is not a horizontal line. Q 2 6 and R 7 -6. The y values are 6 and -6. Since they are not the same, this is not a horizontal line. C -18 3 and D 18 3. Both y values are 3. This is a horizontal line. So the three pairs that lie on a horizontal line are F and M, C and D, J and W. Ready for the next question? Let's go. Let's look at this line on our coordinate plane. We are asked to find the slope of line D. First, we look for two spots where the line crosses exactly through the corners of the grid. Looking at our image, we have two perfect points marked for us. The point at the top, -1, 4. We will label those 2 points as x1 and y1. The point at the center, also known as the origin 0, 0. Label those 2 points as x2 and y2. The formula for slope, m, is m equals y2 minus y1 over x2 minus x1. Now we just substitute the values. Be very careful with the negative signs, as this is where most students make a mistake. M equals 0 minus 4 over 0 minus -1. So we have -4 over 1. So the slope is -4. Ready for the next question? Let's go. Let's have a look at this question. We have 2 points. Point 1, 4, -10. Point 2, 2, 10. We are asked to find the slope of the line. In every point x, y, the first number is x, which moves left or right, and the second is y, which moves up or down. The easiest way to find the slope is to use the formula for slope. M equals y2 minus y1 over x2 minus x1. Let's subtract the y values on top and the x values on the bottom. Remember to keep the points in the same order. Change in y, 10 minus -10. Remember, when subtracting a negative is the same as adding. So this becomes 10 plus 10 is equal to 20. Change in x, 2 minus 4 equals -2. Now divide the change in y by the change in x. M equals 20 over -2. Our slope is -10. Since the slope is negative, this line would be sliding down from left to right. Ready for the next question? Let's go. Let's take a look at this question. We are asked to find the slope of the given line. The easiest way to find the slope is to look at the equation and see if it's written in slope-intercept form. The slope-intercept form looks like y equals mx plus b. In this formula, each letter has a specific function. The y and x represent any point on the line. M, this is the slope or how steep the line is. B, this is the y-intercept, where the line crosses the vertical y-axis. To solve this question, we just need to match the given equation to the formula. The given equation is y equals 7x plus 5. Look at which number is sitting in the m spot, which is right next to the x. Since 7 is the number multiplied by x, that is our slope. Remember, the slope is always the coefficient or the number attached to x, as long as the equation starts with y equals. Ready for the next question? Let's go. Let's have a look at this question, which asks about the lines of symmetry for a square. Now, a line of symmetry is like a folding line. If you fold a shape along that line and the two halves match up perfectly, then you've found a line of symmetry. For a square, we can find exactly 4 lines of symmetry. Let's break down where they are. First, we can cut the square right down the middle in 2 ways: vertical, from top to bottom edge, and horizontal, from left to right edge. If you fold the square along either of these lines, the edges will meet perfectly. Because a square has 4 equal sides and 4 90-degree corners, we can also fold it from corner to corner. The first diagonal is from the top left corner to the bottom right corner. The second diagonal is from the top right corner to the bottom left corner. So, we end up with a vertical, horizontal, and 2 diagonal lines. Remember, this only works for a square because all sides are equal. Ready for the next one? Let's go! Let's have a look at this linear equation. The goal is to find the slope of the line for the equation. 4y plus 48x equals 0. The easiest way to find the slope is to rearrange this equation into slope-intercept form. Y equals mx plus b, where m is the slope, how steep the line is, and b is the y-intercept, where it crosses the vertical axis. Our job is to get y all by itself on the left side. Since we want y on the left and x on the right, we need to subtract 48x from both sides. So we get 4y equals negative 48x. Right now, y is being multiplied by 4. To remove the 4, we divide both sides by 4. So we get y equals negative 12x. Now look at our new equation, y equals negative 12x. Compare it to the slope-intercept form, y equals mx plus b. The number sitting right in front of the x is our m, or slope. In this case, m equals negative 12. Since there is no other number added at the end, our b is just 0. This means that this line goes right through the center of the graph. Ready for the next question? Let's go! Let's have a look at this question. The question gives us 2 points a line passes through, and is asking us to find the slope. Point 1, 0, 3. Those are x1 and y1 values. Point 2, 2, 0. Those are x2 and y2 values. We will be using the slope formula. M equals y2 minus y1 over x2 minus x1. Let's swap the letters for our numbers. M equals 0 minus 3 over 2 minus 0. So, m equals negative 3 over 2. Since the question is asking for the answer to be in decimal form, let's divide 3 by 2. So, m equals negative 1.5. Ready for the next question? Let's go! Let's take a look at this question together. We are looking for lines of symmetry. Think of a line of symmetry like a fold line. If you can fold a shape along a straight line and both halves match up perfectly, then that line is a line of symmetry. Let's look at our 4 shapes one by one. Look at this 4-pointed star. Imagine drawing a line straight down the middle from the top point to the bottom point. If you folded it, would the left and right sides match? Yes. Vertical lines match perfectly. Horizontal lines matches perfectly. It even has diagonal lines of symmetry. Therefore, this shape definitely has one or more lines of symmetry. Now look at this house-like shape. Notice how the roof points to the right, and the top side is shorter and slanted differently than the bottom. If we try to fold it horizontally, the top and bottom won't match. And if we try to fold it vertically, the pointy end has no match on the left side. Therefore, this shape has 0 lines of symmetry, and we call this shape irregular shape. Check out this arrow. If we draw a horizontal line right through the middle of the shaft and the tip, what happens? The top half of the arrow is an exact mirror image of the bottom half. If you folded it over that middle line, they would overlap perfectly. This shape has one line of symmetry, which is a horizontal line. Looking at the last shape, at first glance this looks like a rectangle, but look closer. The left side is shorter than the right side, and the top is slanted. Because the sides are different lengths and the angles aren't square, no matter where you try to fold it, the corners won't meet up. Therefore, this shape has no lines of symmetry. To solve this question, the 2 shapes that have symmetry lines are the 4-pointed star and the arrow. Let's have a look at those graphs. Our goal is to see which graph matches the line mentioned below it. To find out, we are going to use the point test. Let's start with the first graph. The function of the line is y equals 4x. Let's pick a clear point from our graph and test it. As you can see, the question already have 2 points on each graph. Pick the easiest coordinate and test it. If both sides of the function are equal, then the function belongs to the graph. Let's pick the points 1, 2. Now replace the y with 2 and the x with 1. 2 is equal to 4 times 1. 2 is equal to 4. As you can see, this is false as 2 is not equal to 4. Therefore, this function does not belong to this graph. Moving to the next graph. The function of the line is y equals 4x. Let's pick a point to test, 1, 3. Replace the y with 3 and the x with 1. 3 is equal to 4 times 1. 3 is equal to 4. Again, 3 is not equal to 4. Therefore, this function also doesn't belong to this graph. How about the third function, y equals negative 2x? Let's pick the point, negative 1, 2 to test. 2 equals negative 2 times negative 1. 2 is equal to 2. Now this function belongs to the graph as both sides of the function are equal. How about the fourth function, y equals 4x plus 1? Let's test the point, 1, 1. 1 is equal to 4 times 1 plus 1. 1 is equal to 5. Obviously 1 is not equal to 5, therefore, the function doesn't belong to this graph. Moving to the fifth function, y equals 4x minus 1. Let's test the point, 1, 3. 3 is equal to 4 times 1 minus 1. 3 is equal to 3. This function belongs to the graph, as both sides of the function are equal. The last function we have is y equals negative 4x plus 1. Let's test the point, 0, negative 1. Negative 1 equals negative 4 times 0 plus 1. Negative 1 is equal to 1. The function doesn't belong to the graph as both sides are not equal. Ready for the next question? Let's go. Alright, let's take a look at this geometry problem. We are exploring rotations, which is just a fancy math word for turning a shape around a fixed point. In this question, our fixed point is the center of the square, where the x and y axes meet, and we are rotating counterclockwise. This means turning to the left like the opposite way a clock moves. Let's look at part A. It is asking to find which diagram represents a 1/12 counterclockwise rotation. First, we need to figure out what 1/12 of a rotation actually looks like in degrees. Now, a complete turn all the way around is 360 degrees, which is a full circle. To find 1/12, we divide the full circle, 360 degrees, by 12. This is going to be equal to 30 degrees per part. We are looking for the square that has been nudged once only to the left, as 1/12 means moving one part only. And counterclockwise indicates the direction of the movement, which is left. Looking at the options, the first option is the right answer, because you can see that the square rotated one part only to the left. Moving on to part B, the question is asking to find the diagram that has a 90 degrees counterclockwise rotation. Now let me start with the property of a square. A square is very special because all its sides are equal and all its corners are 90 degrees. Because a square is perfectly balanced, if you rotate it by exactly 90 degrees, it lands right back on top of where it started. It will look identical to the original image. So, looking at our options, we have to find a square that looks exactly like the original, since we are looking for a 90 degrees turn. Obviously, the second diagram is the correct one, as it is identical to the original image. Thank you for watching, and see you in the next video.